Hey, what's up? This is Richard from BlenderGrid.com with another tutorial on how to use 2D assets in your 3D scene in Blender. And the main thing you want to make sure of when you're using 2D in your 3D scene is that the 2D assets are facing the camera with the right angle. And Mike is going to show you how to set this up using constraints and drivers for more advanced situations. For example, what if you are using multiple cameras in the same scene and you're switching between them? How do you make sure that the 2D assets are always facing the active camera? And then finally, what if you're using a 360 camera, using a VR shot? In that case, the angle of the camera is not really relevant because it's facing all the directions. So things are slightly different there, and he's also going to cover that. So let's sit back and check out Mike's screencast.
You do know the import images as planes add-on, right?
This is a sidebar add-on.
It's one of the add-ons that's built into Blender by default but not activated. So yeah, if you go to Edit menu, Preferences and Add-ons, it's already installed. So if we go to Import Export, we find it somewhere here, Import Images as Planes. I already have it ticked. You could also search it, Planes, there it is, and activate it. Once you've got it, just delete the old cube, add images as planes, and I can find, don't know what that one is, and there it is, a picture of my website. In fact, I'm going to look at these options for importing again, and what I see is that, there's a lot of options here. Animate image sequences could be useful. I also want to set to omit, and right down here we have options for alignment, which we do actually have an option to face the camera, which is handy. That eye is now facing the camera. Cool, but what if the camera's moving? Let's look at that again. We have an option to track the camera. So it automatically, as the camera moves, the image will automatically turn towards it.
This is a sidebar add-on.
Now, this isn't really part of the tutorial. It's something I can't really leave off. So let's look at the shader editor. This here controls what it does between one pixel and the other. We're going to go to closest, and now we have nice, clean pixel art. In that menu, we ticked track camera to make it point at the camera. So when we ticked track camera, it added a constraint to the plane we created. So this is a copy rotation constraint. It means this copies the rotation of the camera. So if I move around the camera, it doesn't really do anything, but if I rotate the camera, this rotates as well. Whatever axis, it's also rotating, so it matches up, which is okay for this. This is great for an image. Now, if I put this onto local and I select this option, we can see what the local X, Y, Z of the camera and this are. And the camera, actually Z is pointing sort of out of the back of the camera towards the cameraman. Y is up and X is sideways and sideways, which is fine. If I press Alt R to unrotate, the camera is pointing directly downwards. Again, this is fine. And the same is true of images when you import images as planes, or if you just add a plane, it'll come out flat out on the ground, basically, facing upward. But one thing this is not necessarily true of is grease pencil stuff. If I go File, New 2D Animation, and then go to Object Mode, and we go to that, and Local View, we'll see that the Z is up, and so this image is not flat on the ground. If it's copying the rotation of the camera, then we're going to see it edge on, aren't we? It's not really going to work. Well, the obvious solution is, first of all, we are going to lie it flat and rotate through X minus 90. Now it's lying on its back. And now if we go F3, apply rotation. And now if we go to local view, this still matches up. And so this object has Y as its up. and we're able to use the same copy rotation technique that we were able to use with images. The camera banks from side to side as it takes a corner, like a motorbike or a plane or something. And that's cool, but if we've got these objects that are facing the camera, we don't want them to be doing that as well. We want them to remain pointing upwards and just sort of rotate the point of the camera. And how do we do that? Well, using the same eye as before. Well, this is quite simple. I basically turn off those two. You also need to rotate it to stand it upright. And now I can rotate round and it's fine. And also I can look up and down slightly. And you know what? Let's snap cursor to that and snap that. Yeah, so we can look up and down and it's pointing face up, but if we rotate around it, it's still pointing at us, but it always remains pointing upwards. The next question is, what happens if you're using multiple cameras?
This is a sidebar item.
This is a neat trick if you know about it. You know you can have multiple cameras, but generally you've got one in a scene. Well, what if I select a camera? Okay, Control 0 to activate it. Now I can go to the timeline or graph editor or dope sheet or whatever you choose to use that's basically a timeline but better. And marker, you select bind camera to markers. Look, there's a marker that's got a camera icon on it and it's called camera forward backwards. So now it immediately cuts between camera bounce, camera forward backwards, and I can select my next camera, Control 0 again to activate it. Bind camera to markers, and I think it should be bind camera to marker single rather than plural, but it's a really handy trick even though I argue with the grammar of it. So now it's automatically cutting between these three cameras, but the question is, how come as it cuts between these three cameras, are these automatically always facing the active camera? So how are these constantly pointing towards the camera when it's not just one camera, it's fast cutting between three of them? Well, this journey starts in a place I seldom frequent, called the Python console. Now, if I was to start with c.scene, and bear in mind that the use of capitals in here is important, as is the punctuation, because this is code, we can now press tab and see all the options we have. You also see that C is the only capital we're getting. Everything else is sticking to lowercase. Handy. Now, let's type Let's put the mouse arrow on there and type camera. Dot. And tab again. And we have all the things, all the attributes that relate to the camera. Amongst them we find rotation ULA. So, rotate tab ULA. I've experimented with all the various forms of rotation, and it is ULA rotation, which I think is the one that's split into X, Y, and Z. That is the one you're basically using most of the time. Like if I'm rotating an object, let's do that one. Yeah, we get these three ULA rotations. Y, well, these are local, but maybe global would make more sense. Get like that one, and that one. These are the ULA rotations. These are the normal ones. So, also notice that amongst this lot, I have an empty called camera rotation, and upon selecting it, these are purple. The rotation values are all purple, and you may know that that means that they are controlled with drivers. Let's swap this out for drivers. And we see the X, Y, and Z all have drivers attached to them. And what are these drivers? Well, it's a variable. This is the X driver. We'll look at the X driver because they're all basically the same. It's a scripted expression, and find the expression is variable plus 0, 0. So it's variable. I can actually delete that. It's variable. I think this is what pops up automatically. And what is the variable? Well, this is the variable. Now, normally when you set up a driver, this is actually on object. And you've got this little eyedropper to select an object. But what we've done is we've put it on scene, and then we get the option to select a scene. There's only one scene in this blend file called scene, as they often do, and in path we have camera.rotation_ULA.x. Isn't that? Oh, why, yes, it is. That was the... Oh, let's deleted it. Oh, well. That was the... Oh, why, yes, it is. That's the end of that thing we found in the Python console now, isn't it? Yes, it is. And on Y, we have camera rotation ULA Y, and on Z, we have camera.rotation ULA Z. Yeah, you get the message. So basically what this does, by looking at this rather than just copying the rotation, this is an empty that copies the rotation of whatever camera is active at the time. If we look at it here, we'll see that it's kind of not really rotating. The Y is constantly up, and the X is up, constantly pointing towards the right, and the Z is constantly pointing towards us. Now, and the trees, well, actually, we've got the eye actually disappears halfway through this scene because it was cool. Now, the eye, however, that is got a constraint on it, copy rotation, and it's copying this object, camera rotation, which is this empty with all the drivers on it that we looked at earlier, and the trees are doing more or less the same thing, except axes X and Y are defunct. It's only copying the axis through Z, and so we're able to get them, they remain upright to the world rather than upright to the camera, whereas the eye rotates to be the same end up as the camera. So, now you know how to do it with multiple cameras. Let's move on to the next bit where we investigate, what if we don't just want 3 trees, do we? What we use a particle system or geonodes to get like a whole forest of them. How is that going to work? So we've got 2 things going on here. We've got a particle system with the eyes in it, and we've got geonodes with the trees in it. So we'll start with the particle system. We'll look at the particle settings here. There are 100 of them. We might, well, it's set to hair because these are static particles. Obviously, you could use emitter instead. I do actually have to tick advanced. And, well, this one's emitting from the volume. Obviously, it could emit from the surface of the object, but this object is basically a cube, and it's emitting from the volume, so it's points within that cube. I prefer random. Jittered is fine. The velocity actually doesn't matter at all here. Rotation actually has to be ticked and then set to none. Render as object, or obviously collection would work, but here we're using object, and the object in question is I, and we also have to tick object rotation. And then the eye object, this has a rather familiar constraint on it, copy rotation of the camera. This means that all these are basically copying the rotation of the one eye. Now, also we have a grid, and this time, for the for GeoNodes people among you, let's have a look at the geometry node editor. And this may be a sort of fairly familiar geometry node setup. Most of it we have joined with the original geometry. We have a point instance of the collection trees, whole collection unticked, and so that it's not the whole collection, it's a random one of 3 trees. However, we don't have to put a constraint on every different tree in the collection. What we do instead is we can attribute fill. We can fill the attribute rotation with essentially the rotation of the camera. Except that that's not quite right. If we were to do that, well, we get that that same problem. Let's get a timeline in here as well so I can sort of scan through it and you can see what's happening. We get that same problem where no matter how much we tipped up, the trees are not tipping over, they're pointing directly upwards, which isn't really what we want. I mean, it would have worked with the eyes, but what can we do to give them that kind of turning to face the camera but standing upright quality. We rotate them just through Z. That's what this is doing. Yep, rotating through Z. So why, okay, so I can guess, yeah, separate X, Y, Z and combine X, Y, Z, but why are these not both 0? Why is that X consistently 1 point blah? Well, that number is pi over 2. Pi divided by 2. You know the value of pi? Okay, you're still not really helping. What happens if we set it to 0? Well, what happens now is all the trees kind of lay flat. And if we rotate these, they kind of rotate. Ah, I see. What you're essentially doing is you're rotating the plane upwards, because like these planes, using import images as curves, by default they've got Z pointing up. They're basically by default laying flat. So what we need to do is we need to essentially rotate along X to by 90 degrees to get them to point up, and then of course Z copies over. But here, because geometry nodes are just so incredibly mathsy, we've gone beyond using degrees. Instead, we're using radians. And radians, rather than the entire circle being divided into 360, the entire circle is divided into 2 pi, which means 1/4 of a circle, 1/4 of 2 pi, is half a pi. So pi divided by 2. Yep, that's how we get those all standing up there. Speech bubbles have the magical power to remain the same size on screen no matter how far they are from the camera. And how do we make that happen? Well, what we do is we basically make them scale depending on how far away they are from the camera. So let's investigate what's going off here. We actually have quite a few empties to make this be possible. We basically have one empty called distance, one empty called target. Now target is the one that if I move around, it moves the fairy and thus the speech bubble around as well. And distance is basically, if I go to above view, you'll see that distance says the distance from the camera, but it only wants to know about how far it is in the direction the camera's pointing. If you note, if I rotate the camera, you see distance, you can see what's happening there. And though you probably want to rotate this to face, probably want to copy the rotation of the camera to the speech bubble. However, you do also need to have this target in place as well. In fact, let's set that up. We know this one by now. Let's copy rotation and set the target of camera. So now, if I rotate the camera, that speech bubble will remain the same size on screen and will also rotate to face the camera. Distance is a child to the camera, so you basically want to parent the you can see that there, so you basically want to parent distance to the camera. Now distance has a copy location, and its target is target. It only copies it in the axis of Z. But what Z is that? It's using custom space, and the custom space is the custom space of the camera. So why do we need to know distance? What purpose is it actually doing? How is this having an effect on the size of this? And you might have expected this. In fact, I've actually already got the constraints window open here. So if I select this and press that little arrow to make it just get a bit more space for you here, and you can see that this is a scripted expression. It's variable times 0.2, and the variable is distance. It's the distance between the camera and the object distance, and both of them are in world space. Now, of course, you just have, if you want to actually decide what size this is, you basically are just going to change this. Admittedly, I'm only changing the X value right now. And what about the Y scale and Z scale? It's exactly the same. You can use the copy variable and paste variable. Ooh, we don't really need another one. And you can copy and paste that expression var2 into x, y and z. They all need, well, z isn't really doing anything, I guess, but x and y have the same scale. And that allows you to have it the same size no matter how close it is to the camera. But what if you're not using a regular camera? What if you want 2D in your 360-degree equirectangular projection video for use on those phone VR helmets, which are they still a thing? Are people still making 360-degree films? They are pretty cool, right? As you can see from this above view here, the everything is facing the camera. They're not just copying the rotation of the camera. All of these surfaces are now turning to point directly at it. So, what's going off there? Shall we start by selecting an eye and see what's happened? This is using the track 2 constraint. The track axis up is Y, as we've kind of found out for these. Let's go, local, and let's put, we might have to pause it. Oh yeah, so yeah, as it's local is Y. Z is minus Z, pointing directly away. Can we use Z instead? Yes. That would just make it point in the other direction. And it's all world space. With the trees, however, as you know, the trees have to kind of remain upright. So this time we're using a locked track. And this has a locked axis and a track axis. So the track axis is Z, which is sort of facing up from the plane, as we know by now. And that will face wherever the camera goes. And the locked axis, which is Y, is Y. It's the one that is constantly pointing up. And that's basically what you do if you want to work with 360-degree cameras. Because it's not a plane, it's a sphere. They actually have to be all pointing directly towards the camera rather than just facing in the same direction as the camera. I'm pretty certain this is impossible to do in particles. However, I believe it is possible to do in geonodes, but I haven't worked it out yet. If you know how to make everything point directly towards an object in geonodes, then, I don't know, you can finish this tutorial for me, I guess.
This is a sidebar I on tangent I got a topic but it's maybe related. This is a sidebar I on tangent I got a topic but it's maybe related. This is a sidebar